So we're in the README file for the video assignment, upload and download video assignment. You obviously can read the assignment description. You're basically implementing a server that will allow you to upload and download video to a cloud service and then manage the video's metadata. And this, of course, is really just the basic building blocks to get you more comfortable to develop more sophisticated applications. There's instructions here talking about how you can basically clone everything using Git and then import it either in Eclipse or IntelliJ as a Gradle project. It also tells you that you should use the autograding test file as kind of ground truth for what the program's supposed to do. And then you need to implement a bunch of HTTP API endpoint methods so that the autograding test will pass. And this is kind of a synopsis of what you need to implement. You'll need to implement a get method that will return a list of videos that have been added to the server. The videos don't have to persist, so that gives you a hint. You could use a hash map, for example, to store them. And there's a post operation which you can use to upload video data metadata. And this should have a unique ID. The server should be responsible for generating a unique ID. There's also a post endpoint method where you're going to upload the video data. And this should be used as a multi-part request where you have a key and you have the ID, and that's part of the path. And then you would also have the data. And so it kind of explains how you need to create that stuff. And then there's also a way of downloading a particular piece of data, the raw binary data, using another GET request. So we'll take a quick look and see how these things are set up and run with the client test program here in a second. But that's basically what you're doing. We'll also walk through the skeletons a bit so you can see kind of the overall schema of the data, as well as see the various methods and pieces of the code that you have to implement. There's some instructions on how to run the application. It's probably better just to watch Jules's video because that'll show you what to do. And then you can test everything. And when you're done, you can push your code into your GitHub repository, and then we'll be able to review it. There's a bunch of code that kind of comes along with the application. We'll take a look at some of this stuff. And you can, this is actually similar to what you would see if you took a look at the test program. You can create a video and give it its metadata content, its duration, its subject, its title, and so on. You can use a builder in order to do that. We'll take a look at how that works in a second. You can also accept a video from an application request and then do some processing on it. So you can see here that we're going to basically have a request mapping. And you'll see when you look at this that I think it actually uses a post mapping, but it's the same basic idea. And then there's some helper classes, like there's a video file manager that you can optionally use. If you have a better way to do it, feel free to do it that way. But basically it stores videos in a video directory, and it kind of shows how you can use that data. You'll need to have at least one class that's annotated with REST controller or controller. And as you'll see, when you take a look at the skeletons with me in a second, that we already provide you with one of those classes. It's called video controller. And you're welcome to add more, or you can just add new endpoint methods to the video controller class. And again, there's also different ways of using the annotations to designate something handles requests, be it a GET request or POST request, and you're free to do whatever you think is most effective. My recommendation would be to use the GET mapping and POST mapping as opposed to request mapping, because it's a little bit more specific. Okay, so that should hopefully give you some good suggestions on how to implement stuff. So let's go over here and take a look at some of the code. So here is what a video is, and this is code that's provided to you. You should not have to implement this code, and please don't modify it. That's what it says here. Do not modify. And there's a factory method called create that goes ahead and makes an instance of a video builder. And video builder is just a interface that extends builder parameterized for video. So it's kind of an interesting recursive use of the builder pattern. And we've got some methods here that can be called that will set the title and set the duration and set the subject and set the content type and so on and so forth. And you'll see if you take a look over in the test program over here, you'll see in the auto grader, there's a factor method called video that says video.create, and then you use the builder pattern in order to set various metadata information in there, or the test program does that. So that's kind of how that works. Let's go back to video. There's also a whole slew of fields here to store things like the ID, the title, the duration, the location, the subject, the content type, and so on. And then there's a whole slew of accessor methods and modifier methods, mutator methods for setting and getting those fields. If we were really cool, we would probably use Lombok and the data annotation to get rid of having to write all the setters and getters, but it's already here. And then there's a hash code, which is used to basically do a hash that we can use if we use a hash map. And then there's also an equals operator that checks to see if two videos are equal based on the metadata, basically. There's another class called video status. As you can see here, we got video state, which is an enum. We have an instance of this, and then we have a way of being able to have a constructor that sets that state. And as you can see here, we have getter and setter methods for that. So that's just basically used to indicate the status that's going to be returned when you do operations on the video. The application is just a basic Spring application. As always, we annotate it saying it's a Spring Boot application. We have a main program that will run the application class. And that's what we talked about before. That's kind of how everything gets started from the server point of view. That's going to be the inversion of control stuff we've talked about before. And then we have a couple of beans that are used with auto wiring at various points within the implementation. And we have one that will be a bean that creates a video file manager. You can see it just goes ahead and creates a video file manager with the directory that's passed in. And you can go over and look at the resources here to see what that is set to. I think it just set to videos, kind of a boring title, but that's all right. And then we have another bean that will create a multi-part configuration element. And that's needed to be able to support multi-part requests when you make invocations. So you can pass along metadata plus the binary data as well. And you can see that we have a max size that's set here, which is, I guess it's 150 megabytes or so. So you can't get any bigger than that. You can't send videos bigger than that. That's actually not very big, but it's just for showing how these things work. Okay, so that's the application file. Here is the video manager, video file manager. And this basically just allows you to be able to store binary data as in the file system in the videos folder. We already saw that folder. And as you can see here, we basically just go ahead and create the appropriate, well, this is what we use to initialize things. And then we can get the path for the video. And then we can check to see if a video has video data, if it already exists, if it's true. And then there's a method that copies video data. So you can copy data from a video to the output stream. And then there's a save video data, which takes an input stream and then saves the video data. So there's a couple of different things you can do here. Again, you're not required to use this file, but it'll probably save you some time if you do. Then the main thing that you're going to have to implement is the video controller. And some parts of it come out of the box. Again, if you really want to re-implement it, you're welcome to do that, but it's probably easier just to start with what's here. As you can see, the video controller is a REST controller. So therefore, it can be the target of HTTP requests. And we have a bunch of strings we define here, which are going to be used as symbolic names. We could probably do some other fancy things if we really put our mind to it and make it a little easier to write the test program using these constants as well. I don't think it does that, but it could. And you can see here that we have, the data parameter, which is called data, the ID parameter, which is the string ID, the video source path, which is /video. That indicates where we're going to handle the video service. Then we can have individual video path, which is the video service path, /ID parameter. And we have the video data path, which is the individual video path plus data. So these are just ways of being able to indicate specific endpoints that we need to have implemented. Down here, you can see we have our video file manager, which is auto-wired. So that gets connected up. And that, of course, gets resolved by this nice little bean over here. Video file manager bean is connected to that. So that's what will be used to initialize this. So we don't have to do this is basically dependency injection 101. We don't have to write the constructor. We just write the factory method that makes one of these things, and Spring connects them together. Down here, then we have a couple examples of endpoint methods for HTTP. And you can see this one is a get mapping, which is for the video data path, which is this guy up here. And this is used if you want to download a particular video. And the way this works, as you can see, is when you make the call, and we should probably, let's go take a look over in the auto grading test. There's undoubtedly something here that will get a video. Here we go. So you can see that we go ahead and we call get video, we pass it an ID, and we mock up a get request where we pass in this video path followed by the ID, and that's going to go ahead and invoke this call right here, which is connected to that, and it'll go ahead and basically get the video. Now, you have to write some code here. It's pretty simple, actually, just a couple lines, but basically you have to go ahead and check to see if you can find a video with that ID, and if so, you're going to go ahead and set the information, and as you can see, you set the content type, and then you go ahead and copy the video data into the responses output stream. So that's how that'll get sent back to the caller. And if for some reason something goes wrong, then we'll return, error code 404 and say we can't find the video, sorry. So that's kind of the basic idea for download video. You just have to fill in a few little pieces. Here's the skeleton for uploading a video. As you can see, take a look at the auto grading test here. We got add video. Notice how get video used the get request and add video uses a post request. That's keeping with the spirit of things we've talked about before, where get requests are used to get a view of the data, whereas post requests are used to update or modify the data on the server. And in this case, we're going to say we want to post to the video, and then we go ahead and provide the content here, which is going to take in this video and then write the values as bytes. And then we give it the content type. We say it's a JSON, and that will then upload that to the server, and then we get a copy of it back. And there's a couple other variants of this, which we'll talk about briefly here because they're also important. But let's go back first and take a look at the video controller. So you'll have to also write the code to find if the video exists and assign it to the video variable. And again, in this case, we're going to save the video, and then we're going to update the video status, and that's what's going to get sent back as the return value here. And once again, if something goes wrong, we send the error code back saying video not found. Now, this comment isn't as useful as it could be. It probably should really say, there's some other methods you have to implement in order to be able to provide the full complement of endpoint methods expected by the client. It talks about creating one or more Spring controllers. We already got one, video controller. If you want to, you could create other video controllers or other controllers, but you're probably better off just adding other endpoint methods that are either post or get methods. And to figure out what you need to add, you can take a look down here at some of the other pieces of code, right? So like get video list, which is described in the README file. As you can see, what it's going to do is it's going to send a get request to the server with just /video. And what you get back in return is a collection of all the videos. So you'd have to write that endpoint method that would field that request and then go find all the videos that are currently uploaded and return them as a collection. So that would be one thing that you could do. And then there's also things here about setting, video data. That's also described in the README file. And again, you have to implement the endpoint that handles this appropriately. And as you can see here, it's creating a multi-part entity that's going to have the contents, which is the file, and then also the content type, which is a multi-part form data value. And we get back a status. So again, if you just look through this stuff, you'll see these different little helper methods. That'll give you a very good idea of what to expect, what you have to implement for your endpoint methods in the video controller, if that's what you choose to do. And then over here, we've got a bunch of tests. As you can see, if you look at the top of the file, these are Spring Boot tests. So they run with they're designated with the @test annotation. And you can see here that this will go ahead and make a video. It'll basically make a call to the server to add that video. And then what you get back would be the video. And then we go ahead and sort of do some sanity checking to see whether what you got back is what you sent. And if you don't get back what you sent, then obviously something's wrong. And then there's also another test here for adding and getting a video. So we're going to add a video first. Then we're going to go ahead and get the list of all the videos. And then, of course, what we get back should contain the video that we just sent up there. So you'll have to figure out how to write that code. And then we've also got some other things here for testing, adding video data. See some examples there. And then there's another couple tests that check to make sure that things work correctly if you give erroneous input. So if you try to send up data, you try to send up a video that doesn't exist, there's a method called get invalid video ID. Let's go take a look at that real quick. So this basically just generates an invalid ID that will not match anything. And it does that by taking a look at what's already there and then going ahead and creating a number that doesn't exist in that set or that collection. So these things should properly fail, which is what you would expect them to do. Okay, so that's basically what the skeletons look like. Again, this is the test program, and your mission, should you choose to accept it, is to make sure that the test program that you're writing or the test program that you're given works with the actual application. And it should be pretty easy to figure out how to run all this stuff. But if you get confused, I posted the link to the video that Jules made where he kind of walks through running the tests.